Hello. The objective of this video is to determine how changes in data affect the measures of central tendency. Now, to refresh your memory, the measures of central tendency are mean, median, and mode. Sometimes they'll include range as a measure of central tendency, but we're not looking into that one right now. The mean is the average, which means when you add up all the numbers in your data set and divide by the number of numbers in the data set. The median is the middle. It's when you take the numbers, put them in order from least to greatest, find the middle numbers. If there's two of them in the middle, you average them to find the median. The mode is the number that occurs the most. Now, outliers are values that are much higher or lower than the rest of the data. You may have heard that's 1.5 times the interquartile range. We're not going to get that specific with it. All you do need to remember is that on a box and whisker plot, it needs to be shown as an asterisk, and that they're usually higher or lower than the rest of the data. All right, here we have a set of numbers, 2, 4, 5, 6, 8. That is an 8 in those. If I add those all up, I get 25. Divide by the number of numbers, 5. I get a mean of 5. They're already in order. The middle number happens to be the 5. None of the numbers repeat, so there is no mode. Now, if we take that same set of data and we add in a 5, we now have 2, 4, 5, 5, 6, 8. When we add these all together, we're going to get 30. And now instead of 5 numbers, I have 6. When I do that, I get an average or mean of 5. Looking for the middle number, I now have these two numbers in the middle. They end up being 5. The mode, now there is a mode. There wasn't any before, but now the number 5 repeats, so it is the mode. What happens if we added a 10 into the original list? Well, we now have a total of 35 out of 6 numbers here. 35 divided by 6 is going to give me 5 and 5/6. The median is still going to be, well, now it's going to be these two numbers added together divided by 2. 5 and 6 added together give you 5.5. So when we added a bigger number, our mean got larger, our median got larger. The mode, in this case, didn't change at all. It's going to still be none, like the original. Let's take a look at what happens when we add a number that's smaller than the rest of the numbers here. If we add 2, add them all together, we're going to get 27 over 6. 27 over 6 numbers still. 27 divided by 6 is going to give us 4 and 2/6. So 4 and 2/3. Now, the median is going to be these two numbers here, 4 and 5. Add them together and divide by 2, we get 4.5. The mode is the number that occurs the most. This time the mode is 2. Now you'll see when we added a lower number, our mean or average got lower. When we added a number that was higher, our mean or average got higher. Same thing happened with the median. The mode, though, mode's kind of a lucky chance. If the number you add happens to be the same as one of the other numbers in there, it might change the mode, it might not. That's one you have to look at the data for. There's no pattern with mode. However, there is a pattern with the median. In general, when you add a number greater than the median, it will either become greater or stay the same. When adding a number less than the median, it will generally make it smaller or stay the same. The stay the same part there is because you may have multiples of that median number. Let's say we have this group here. We have 3, 4, 5, 5, 8. the middle number here is the 5. When I add in a 6, this number is greater than that, and I said it's either going to get bigger or stay the same. Well, the middle number here is going to be the two 5s, which when you average them still gives you 5. So although it did shift the numbers over this way a little, shift the median over a bit, shift the median over this way just a little bit from the 5 to the middle of the 5 and 5, it didn't change the value because of that repeat in there. Now, if I add one smaller than it, I would expect it to shift slightly to the smaller numbers. It does come between the 4 and the 5. The median here is now 4.5. So you've got to look at the repeating values in the middle there. If you add in a number that's greater than the median and there's no repeating in the middle, it's going to make the median larger. If you add a number less than the median and there's no repeating in the middle, it's going to make the value smaller. If there's repeating in the middle, it could stay the same. Let's take a closer look at mean. Here we have the set of data, 2, 4, 5, 6, 8. The sum of them is still 25. Now I'm going to add a number to the beginning and the end. I've added a 1 and a 10, that's a total of 11, which means that I've actually got 36 out of 1, 2, 3, 4, 5, 6, 7. Which means my average is 5.2, or 5 and 1/7. We'll write like that, 5 and 1/7. The median, the middle number, is still going to be whatever the middle was before, because we've added one to each side. Take one off each side, take one off each. Median is still going to be 5. Adding one above and one below did not change the median at all. Because if you think about it, when finding the median, you take one off of each side. If you added one to each side, to both sides of the median, it's not going to change the median. Here we added a 9 and a 1. The median is going to stay a 5. 9 and a 2. The median is going to stay a 5. The median is not affected when you add something to above or below, above and below together. Okay? The mean, though, when I add these together, I'm going to get 35 over 5, which is 7. 35 over 7, which is 5. The mean here is not changing. It stays the same. Here, though, I've added 1 to both sides, and I'm going to get that 36 over 7, which is going to give me that 5 and 1/7 here. So when you add 1 to both sides, if the average of those two numbers, 9 plus 1, gives you 10, divide by 2. If the average of those numbers happens to equal the average that you started off with, it's going to stay the same. If the average is higher of those two numbers, then it's going to make your mean or average higher. Same can be said true for the making the average lower overall. So when you add data, you got to keep that in mind. When adding outliers, if you added an outlier, you got to be careful. It's going to have an effect on the data. Here I've added outliers, a number much larger than the other numbers in here. When I add these all together, I'm going to have 25 plus 17, 35, 42. So I'm going to have 42 divided by 6. I'm going to have an average of 7. The median here is going to be 5.5. It's halfway between these two. When I add, now you'll notice that the mean did go up. I added a number that was larger than the mean, and the mean did go up. I expected that. The median went up by 0.5 when I added one larger here. Which one went up more? The mean went up more. What if I add 100? If I add 100, is that going to change the median? Well, the median median is going to become the 5.5 instead of the 5. But the mean, when I add all these together, I get 125 divided by 6, which is going to give me 20 and 5/6. That's a big difference. The mean is greatly affected by outliers. The median, however, is only minimally affected by outliers. Let's see if the same is true when we add a negative in. You add a negative in, you're still going to go right to the middle here. You're going to get 4.5 for the median here. Only a change of 0.5. The mean, you add these all together, you get 25 minus 7 is 18. Divided by 6 is going to give you 3. All right? So you end up getting a much smaller mean when you add in a low outlier. Bottom line there, the mean is greatly affected by outliers, while the median is not. Adding data greater than the mean will increase the mean. Adding data less than the mean will decrease the mean. Adding data that's equal to the mean will have no effect on the mean. Outliers have a greater effect on the mean itself than they do on the median. Thank you. See you in class.